So hello everyone. So we will move on with the next topic, that is on hypothalamus. So a very important essay question, and also we can expect a short note. So essay question will be like connections and functions of hypothalamus. Okay, and anatomy they generally do not include under essay, but it is better to just start with some introduction about location of hypothalamus. So for that purpose, I have just put this picture to just make you guys understand on location. So if you observe this picture, this is your optic chiasma, this is your thalamus, and this is your mammillary body. Okay, so the portion that is between or sandwiched between this optic chiasma, mammillary body, and below your thalamus is called as your hypothalamus. Hypo means below, right? So this portion I can say is called as your hypothalamus. Okay, so it is going to be between your optic chiasma and then mammillary body. So this portion is your hypothalamus. Okay, and if you take, so if introduction, how will you give this? You can give this, it is a structure that is below, that is present below your thalamus, and it is present between your mammillary body and then your optic chiasma. Okay, so if you are going to give this introduction, it is more than enough. And I hope you all know about various groups of nuclei. Okay, so I just don't want to get into its details, but I'll just tell you in short. Okay, so suppose this box is your hypothalamus. So this is your anterior relation. Okay, this is your posterior relation, and this is your lateral, and this is your middle or your medial. Okay, so we'll just ask, it is a middle group. Okay, so hypothalamus is going to consist of many nuclei that has been actually put into 4 groups. We have an anterior group, we have a posterior group, we have a lateral group, and then we have a middle group, not medial, middle group. If you take anterior group, we are going to have a preoptic area and then a supraoptic. Okay, so all that ends with optic will be coming under this. Okay, so preoptic and then supraoptic. So these are something that comes under your anterior group. And then if you take your posterior group, under posterior group will be mostly having your posterior hypothalamic nuclei and then your mammillary nuclei. And similarly, if you go for lateral group, we'll have lateral hypothalamic nuclei and then lateral preoptic nuclei. And middle group, if you take, we'll be having a ventromedial, and then we will be having a dorsomedial nuclei, and then we'll be having an arcuate nuclei. Very important. So we'll be having arcuate nuclei, we'll be having ventromedial nuclei, and then we'll be having a dorsomedial also. Okay, so these are some relations, or I can say different groups of nuclei that are present. Okay, so with this introduction of structure of hypothalamus, let us move on with our essay question. So first side heading will be connections. So always remember connections. If you are going to write connections for any structure, so now we are studying hypothalamus. Okay, so we'll be studying about cerebellum, we'll be studying about basal ganglia. So one important side heading will be connections. So you need to include 2 components of connection. One is the afferent component, another one is the efferent component. So if you take afferent connection of hypothalamus, so it is olfactory area, frontal lobe, hippocampus, thalamus, amygdala, RAS. So we have another structures also like your retina, all that. Okay. So just get a glance of it and write whatever structures you remember for afferent. Okay. So any area that is in surrounding of your hypothalamus, you can include. But if you take efferent connection, primarily we have only these 4 efferent connections. So what are they? So there are some fibers that are raised from hypothalamus. It goes all the way to your spinal cord. It goes to your brainstem, your autonomic nervous system, and then your pituitary. Very important efferent connections. Okay, so you should mention about afferent. You should mention about efferent. So I hope you all know what is an afferent and efferent connection by now. Okay, so this is what you need to write. So in your exam under connections, if you are just going to give this side heading afferent and efferent connection, and you're going to draw this flow chart, it is more than enough. But under connections of hypothalamus or your limbic system, whatever they ask, you need to specify a very important connection that is called Papez circuit. Okay, or Pape's circuit or Papez circuit, however you want to pronounce Pape's circuit. See, this Pape's circuit, so you would have studied electrical circuit in your physics. So how will you study a circuit? You are supposed to mention its components. Like if you take, there will be some circuits which will have a galvanometer but not an ammeter. There will be some electrical circuits that will contain an ammeter and not a galvanometer. There will be some circuits which will not have anything. Instead, they will have some other devices. So when a circuit is being given to you, you need to mention its components. And then you will be talking about how the connection is going to go all the way. If you remember a physics circuit like this, okay, just now you would have come with your need, right? So resistor, and then we'll be having a bulb, and then we'll be having a voltmeter or an ammeter or a galvanometer. So when somebody asks you to read this circuit, you'll be telling the following components of the circuit are. Right? Similarly, if you take Pape's circuit, first thing we need to mention its components. So if you mention its components, the primary components of this circuit is actually made up of structures related to your limbic system. Okay, so I hope you all know what is a limbic system. The limbic system is nothing but basically it is concerned with your emotional expressions. Okay, so this circuit is made up of certain structures that is concerned with your limbic system. Okay, and the next thing, what is the purpose of this is, its main purpose is related to memory. So when we have a separate session on memory, we'll be discussing in detail about Pape's circuit, but just understand it is helping in consolidation of your episodic memory. Okay, I do not want to get into the details of it because it will delay my session. Okay, so just note this point alone. Okay, so if you take, it is responsible for consolidation of your episodic memory. Okay, so episodic memory I can say, right? So I hope you all notice an episode. Okay, so consolidation of your episodic memory. So you should write it is circuit that is made up of or that consists of components concerned with your limbic system, and its main function is related to your memory, or if you want to be more specific, consolidation of your episodic memory. Okay, now why are we studying this under your hypothalamus is, see, this Pape's circuit is also going to contain connections that is related to your hypothalamus also. Okay, so if you just know this thing, see, this is a curved structure. Okay, so we will be having, so just now we saw in this picture, right? If you see, we have this mammillary body. Okay, and we'll be having something called a cingulate gyrus. So I hope you all notice cingulate gyrus. So corpus callosum, it's a structure that is actually going to cover your corpus callosum. So what is going to happen is, this Pape's circuit, the fibers are going to begin from your hippocampal formation. Okay, so hippocampal formation, if you take it, is a part of your limbic system, right? So hippocampus, I hope you all know that. So it is going to begin from your hippocampal formation. It runs all the way to your mammillary body, and from mammillary body it goes to your anterior nuclei of your anterior nuclei of the thalamus, and from there it comes to cingulate gyrus, and again from cingulate gyrus the fibers, it goes to your hippocampal formation. Okay, so actually if I have some sagittal section of brain, I'll be able to explain. Unfortunately, I don't have one. Okay, so see, I can just tell something from here. So you will be having your fornix coming all the way, right? So from this, so you'll be having your hippocampus. From there, it goes to your mammillary body. From mammillary body, it goes to your anterior nuclei of thalamus. From there to cingulate gyrus. And it comes via your parahippocampal gyrus. And again, it is going to reach your hippocampus. Okay, so this is the circuit. Okay, again, do not worry. In memory, we'll be studying in detail. I just wanted to give you an orientation how it goes. Okay, so you're going to start somewhere here, come to mammillary body, goes to cingulate gyrus, and via your parahippocampal gyrus, it is going to come again to the hippocampus. Okay, so that is what you need to understand. And you know, I hope you all know what is a cingulate gyrus. It is just going to cover your corpus callosum. Okay, so this is your Pape's circuit that you must specifically mention separately in connections of your hypothalamus. Okay, so with this, we will move on to the functions. See, this structure is actually going to play a very important role now. Currently, we are all in lockdown, right? So very important part of the brain that is functioning for us for all these days, and it is yet to continue, I believe. So what is that? If you take the first and foremost important function of hypothalamus, which is also a very important short note, is your food intake. So we all know in lockdown, we tend to take so much of food, right? Because we sit idle for a long period of time without any activities. Okay, so we sit in front of TV or Netflix, water. So we tend to take something. So all this food intake is actually regulated by hypothalamus, a very, very, very important function. Okay, so first function is regulation of food intake. Second thing is regulation of body temperature. What is that? Regulation of body temperature. So when you have food, you tend to drink water. So there should be some mechanism to control thirst. So the third important function is regulation of thirst. Okay. Next, if you take regulation of stress. So nowadays for you people, whether exam is on September or it is going to be postponed, or I have so much to study. So all this. Okay, so suddenly you feel so stressed, and after some time you just get back to normal. So all these are again by your hypothalamus. So you take food, okay, you check your body temperature, you have thirst, so you went and drank water. You came and you're sitting and you're thinking about your exam, so you got stressed, so that is regulated. And finally what you do, you all sleep. So eat food, think about your life, you sleep. Okay, so regulation of sleep. Finally, either you get a reward or a punishment. Okay, so I have just put this so that you will be able to get these pictures as a story. Okay, so you eat food, your mom is seeing, see, he has so many duties, he's eating food still. Okay, see, you are eating food, and this, sorry, it did not actually fit into the story. So you just check the body temperature. Okay, whether you are free from corona, then you go drink some water, you sit, you just think about your life, so you get stressed, and finally you sleep. And result, either a reward or a punishment. So these 6 are your primary functions of your hypothalamus. Apart from that, we have some more functions that has to be discussed. Regulation of ECF volume, that actually I will cover with regulation of thirst. And then endocrine role. So we all know, you'd have studied endocrinology and you have come, right? So hypothalamo pituitary axis, hypothalamo pituitary axis, right? And role in circadian rhythm. Again, you would have studied in endocrinology. Okay, if you remember melatonin, it's a very important hormone that is going to take part in your circadian rhythm maintenance. Okay, 24-hour cycle, right? So our body will be tuned to do some functions at some particular point of time in day and night. That is your circadian rhythm. That is again going to know primarily because of hypothalamus. And finally, if you remember, there were some efferent fibers that is going to connect your ANS. So control on ANS. So taking food, you check body temperature whether you're corona free, and then you go for drinking some water, you sit, you just think about your life, you get stressed, so you sleep. So there is going to be some reward or punishment, okay, in form of exams or results. And then regulation of ECF volume, endocrine role, all that. Okay, so first we will start with food intake, a very important question. Okay, I don't know why examiner loves this question to ask, but it is very important, but very simple also. Okay, so we'll just go as a story. See, we have 2 nuclei. So we all know that, right? So we have something called VMN, ventromedial nuclei. If you remember, it belongs to middle group of your hypothalamus. And we have lateral nuclei, okay, lateral hypothalamic nuclei, that is going to belong to your lateral group. So these 2 nuclei are the primary nuclei that involves in food intake. Always remember, when you enlist these functions in your exam, your first point should be what is the nuclei of your hypothalamus that is meant to do this function. So if food intake, you have 2 nuclei, VMN and then LN. Okay, so ventromedial nucleus and the lateral nucleus. So what is its role, we will see. If you take VMN is referred to as satiety center. What is it referred to as? Satiety center. And your lateral nucleus, if you take, it is referred to as feeding center. So in a quarantine, we have this lateral nucleus that is actually going to be active for a longer period of time. Okay, because if this lateral nuclei is going to be stimulated, we take in so much of food. Like when we see a cinema, VMN nucleus is concerned with satiety center, which means it is going to inhibit the food intake. Okay, so the amount of food. Okay, so our food intake is regulated by 2 nuclei. We have something called as a satiety center that belongs to your ventromedial nucleus of your hypothalamus. And we have a lateral nucleus that is responsible for feeding center, that is called as a feeding center. So remember, here I have put a red sign or a negative sign, and here I have put a positive sign, which means this VMN is going to have an opposite effect on LN, which means if VMN is stimulated, LN is going to be inhibited. If VMN is inhibited, LN is going to be stimulated. Okay, so it is going to have an opposite effect. And this LN is going to have a positive effect on food intake. Okay, so if suppose your LN center is activated, so I told you it's a feeding center. So if it is stimulated, it makes a person to take in more amount of food. Okay, so always remember this circuit. VMN is going to be inhibitory to your lateral nucleus, whereas your lateral nucleus is going to be a stimulatory effect on your food intake. Okay, so these three are the components. So the first point, you will write both the nucleus and its corresponding center name. Okay, so VMN satiety center and this is feeding center. Now, experimental evidences. Okay, so how actually they came to this theory and how actually they were able to study the individual contribution of these nuclei. See, I told you VMN is concerned with satiety center. VMN is concerned with satiety center. அதாவது நீங்க ரொம்ப சாப்பிடும்போது இந்தா சாப்பிடாத. If you are going to consume food for continuously, then you will be under a trouble. Please stop it. Okay, அப்படின்னு வந்துட்டு parents will tell, in our body it is going to be intimated by a VMN nucleus, which means this VMN is concerned with decrease of food intake. அதிகமா சாப்பிடுறேன்னா நீ சாப்பிடாத, இதுக்கு மேல உனக்கு கெட்டது, குண்டாயிடுவேன்னு சொல்லிட்டு this VMN is going to send some inhibitory signal. So just imagine if I am not having VMN, okay, or some VMN is going to be destroyed. What is going to happen? This LN is going to be only there, right? And I told you LN is a feeding center and it has a positive effect on food intake. So what is going to happen? You are just going to consume food as you like. Okay, kitchen gaaliya irukkum, you will start eating. Okay, so what will ultimately lead on to? It will lead on to obesity. Please understand, obesity is a multifactorial disease. Okay, there are many factors that will actually govern obesity. One obesity that we have is something called as hypothalamic obesity. Okay, so experimentally they found if there is destruction of your ventromedial nucleus or a satiety center, there is no inhibitory signals to your lateral nucleus, and so there is increased food intake that leads on to obesity. That is called as hypothalamic obesity. Next, aphasia. Aphasia means what? It's not taking any food, right? That is because of two things. See, நீ சாப்பிடவே மாட்டேங்கிற, which means either your feeding center has to be destroyed or your inhibitory center is going to be activated more. Okay, so aphasia was because of destruction of your lateral nucleus and increased activity of your VMN nucleus. Are you able to understand all these? Okay, ரெண்டு nuclei தான், இதை வச்சு தான் நம்ம ஃபுல்லா விளையாட போறோம். Okay, first we saw hypothalamic obesity, that was because of destruction of your VMN. Second, we are seeing something called aphasia. Aphasia and absence of food intake. Phagia means taking food. Aphasia. So that was because of two things. One is destruction of your lateral nucleus or increased activity of your VMN nucleus. VMN, sorry, VMN nucleus, VMN. Next, hyperphagia. Okay, increased food intake. Okay, that is because of increased activity of LN. Increased activity of LN. If you know hyperphagia is going to go for a very longer time, then it might also lead on to hypothalamic obesity. But the primary cause of hypothalamic obesity is VMN destruction. But hyperphagia, if you take, there is no destruction of VMN, but your lateral nucleus is overactivated. Okay, that is going to dominate the effects of VMN. You need to understand the difference between these two. Okay, so satiety, feeding. Okay, the signals experimentally, these were all the conditions that were observed when there is some disturbance in the nuclei. I hope you are all clear till this. Okay, so now how this VMN or LN is able to sense that you have taken in so much of food. Okay, how it is able to quantify your food intake. That was actually explained by a glucostat hypothesis. See, glucostat is referring to a cell, to be more specific, a neuronal cell that is working on based on presence of glucose, or that requires glucose for its function. So neuronal cells that depend on glucose for its function is called as a glucostat. So there is something hypothesis called glucostat hypothesis that operates for regulation of food intake. So we will see what all happens. So I told you, I gave you the story in the slide. Okay, VMN oda work enna appadina, when you are consuming more amount of food, it gives you a signal in nariya saaptite idukku mela pannena unakku prachana, please stop. Okay, so it is sensing your amount of food intake. So food, what we actually in biochemistry you would have studied, right? So we know mostly calculated in form of a glucose or a fat or something, right? So this VMN is going to know what to say. It is dependent on glucose levels, which means if there is insulin, if there is more amount of glucose, this VMN is going to uptake all the glucose. Okay, so that is going to provide some form of an energy to VMN that is going to send an inhibitory signal. Please understand, the moment you take in food, you are going to have more amount of glucose in the blood. And if you are going to be a non-diabetic patient, there is also going to be sufficient amount of insulin. So when there is insulin, when there is adequate amount of glucose, there is going to be uptake of glucose by a cell, right? So this VMN uptakes glucose inside it in presence of insulin, and that is going to send an inhibitory signal to the lateral nucleus. So in an hyperglycemic condition, which in normal individual happens after a postprandial condition, is because of this uptake of glucose. That is why person stops eating after some time. Okay, pasikila podum enakku vairu full aiduchu. All that is because you have given sufficient amount of glucose for VMN to be activated. That's it. Okay. Similarly, if you take hypoglycemia, there is decreased glucose, so there is decreased insulin, so there is decreased uptake of glucose into your VMN, so it is not activated. So if VMN is not activated, your LN is going to be activated, so there is increase in food intake. Okay, next in diabetes mellitus. I hope you would have done diabetes mellitus in biochemistry. So if you take, there will be polyphagia, polyuria, polydipsia, all these poly components. And one important thing is polyphagia, which means increased food intake, right? So if you take in case of a type 2 DM, we all know there is, I can say, there is some defect in the receptor, so that there is no uptake of insulin. Or in case of type 1 DM, there is going to be absence of insulin, I can say. So if you take in DM, there is again going to be polyphagia. If you see, there are patients who just taken food continuously, right? Why? Because I told you, for uptake of glucose, you need insulin. That's a very important point. In case of diabetic patients, insulin is not going to be present. So uptake is going to be inhibited. If uptake of glucose is not into your VMN, then it is not activated. If it is not activated, you have LN that is going to do its role in a very efficient way that leads on to increased food intake. Okay, so this is how, or this is why diabetic patients, they are polyphagic, because of this reason. Okay, very important. So how this machinery, okay, this simple mission, how it works is explained by a glucostat hypothesis. So when there is hyperglycemia, so basic concept is VMN வேலை செய்யணும். If it has to work, it requires two things, a glucose and insulin. Okay, அது இருந்தா VMN is going to be activated, henceforth LN is gone. This is the basic underlying concept. So with this, they are explaining in case of an hyperglycemic, in case of an hypoglycemic, and in case of a diabetic mellitus patient. Okay, now this again a very important MCQ that you can get. So there are some peptide hormones, I can say, that is going to play an important role in regulation of food intake also. So along with whatever glucostat hypothesis we saw, we have some other hypotheses also. So if you take these peptide hormones, there are some peptide hormones that is going to be synthesized in your hypothalamus, there are some peptide that is also going to come from other sources. So if you take hypothalamic peptides, we have following peptides: peptide Y, orexin, ghrelin, MSH, CRH, and ACTH. So these peptides I have classified into two again based on its role in food intake. If there are hormones, okay, so positive means hypothalamic peptides that induces food intake, which means it is going to work with LN, right? Lateral nucleus oda சேர்ந்து நம்மள பழி வாங்குது அப்படினா food intake அதிகமா பண்ண வைக்குதுனா these are all the peptides, and these are all is going to do some good thing to us. It is actually going to decrease the food intake, so it is a negative hypothalamic peptide. So you should know the source of this peptide Y. If you take it as an hypothalamic peptide, we saw that is going to stimulate your food intake. The source is mainly from your arcuate nuclei of your hypothalamus, an important MCQ. Okay, source of peptide Y is going to be arcuate nuclei of your hypothalamus. Similarly, if you take orexin, it is going to be from your lateral nuclei of the hypothalamus, and we have another group of hypothalamic peptide called as ghrelin. So what are the role of all these? All these are going to be concerned with what? Positive regulation in your food intake, or it just stimulates your food intake. And all these hypothalamic hormones, MSH, CRH, ACTH, all these are going to have a negative role on food intake. Others, if you take, we have leptin. Okay, so this is actually a lipostatic theory. Lipostatic or lipostatic. We saw glucostatic hypothesis, right? Similarly, this is your lipostatic hypothesis or theory. So if you take, according to that, we have some fat that also plays a role in food intake. So if you take leptin, this is actually a hormone from your synthesis from your adipose tissue, which means you consume more amount of food. Okay, so we all know, right? It is going to, so if there's excess glucose, it is going to be converted to, some will be converted into fatty acids and all that, right? So that is a source of your fat. So those is going to go and accumulate and form the adipose tissue. So when there is leptin synthesis from this adipose tissue, that is going to inhibit your food intake. So if you take, more is the size of the fat, more is the leptin produced. A very important point. Okay, so the amount of leptin produced is directly proportional to the amount of fat available, and this is going to have a negative effect on your food intake. Okay, that is called as lipostatic theory. Similarly, if you take gut peptides, you have this gut peptide theory. So you have some hormones like your somatostatin. Okay, you have some this CCK, and you have something called peptide YY. Peptide Y, if you take, it is an hypothalamic peptide. Peptide YY is a gut peptide. So all these are going to decrease the food intake. So ultimately, we have only 3 hormones or 3 peptides that is going to increase the food intake, or it works along with LN, is your POG. Okay, like your PUBG, it is POG, peptide, orexin, and then ghrelin. Okay, all others are going to have a negative role with your food intake. That is, it is going to inhibit the food intake. You need to write this much. That's why I gave you an elaborate explanation. Okay, so what are the nuclei present? What is its center? Experimental evidences, all the various hypotheses, how it works, so glucose, 3 conditions, and finally the peptides. If you include all these, you will get 5 on 5. Okay, not 5 on 5. Let's not know actually. You will at least get 3.5 or 4. That is for sure. Okay. So with this, we'll move on to the other roles. We'll just complete it in another 15 minutes. Okay, so if you take for body temperature, so as I told you, any function you should include what are the areas that is going to play a role. So if you take, we have this preoptic area. So we saw that is going to primarily be in your anterior group, and we have this anterior hypothalamus and then posterior hypothalamus. So we have these 3 that play an important role: preoptic, anterior, posterior. So body temperature means either you can have an increased body temperature or you can have a decreased body temperature, right? So we'll see what all happens if there is an increased temperature. How your body gets back the temperature to optimum. So whenever there is increased temperature, we have this anterior hypothalamus being stimulated. So how it is going to bring back the temperature? So it is going to act on your cutaneous blood vessels, and it is also going to act on your sweat glands. So you all know, right? So sweating, if you take, it is a mechanism that will actually tend to cool your body. So increased temperature acts on anterior hypothalamus to actually what? It is going to increase your sweat secretion. And cutaneous blood vessel. So either you will have a vasodilation or you will have a vasoconstriction. Just think, okay, whether it is vasodilation or vasoconstriction. So if you take, you have two mechanisms, cutaneous vasodilation and sweat secretion. So these two will actually what? Bring down the body temperature. Okay, so when there is cutaneous vasodilation, okay, so blood vessels will dilate. So there's going to be what? Decreased pressure. So that I can say there's decreased blood flow. So there's going to be decreased metabolism of the tissues. So temperature is going to be reduced. Okay, so whenever there's increased temperature, anterior hypothalamus, cutaneous vasodilation, and the sweat secretion. Secretion spelling is wrong. I'm really sorry for that. Okay. Similarly, if you take, whenever there's decreased temperature, we have this posterior hypothalamus that is going to be stimulated. That is going to cause cutaneous vasoconstriction. So there will be increase in BP. So there's going to be increase in your blood flow, increased metabolism, increased temperature. And we have rigors. That is increased muscular contraction activity. Okay, in winter seasons, you all would have observed, right? So shivering, it's one of a mechanism, right? So that is actually, I can say, is rigor. Okay, so whenever there's increased muscular activity, then I can say it is a rigor. So the compensatory is going to be cutaneous vasoconstriction and rigor. So anterior for your increased, posterior is for your decreased temperature. Okay. So with this, we have completed the next important function, role of body temperature. Okay, so preoptic, anterior hypothalamus, posterior hypothalamus. So what happens in case of increased temperature? What happens in case of decreased temperature? Beautiful. The next is regulation of thirst. So you take food, you check temperature coronavirus, then you finally drink some water. So thirst center. Okay, so when will this thirst center be regulated? Or when this will be activated? One is hypertonicity. What is this hypertonic condition? When you have more amount of solutes, which means your normal, you would have studied in counter current mechanism. I took that session, right? So normal plasma osmolarity is 285 to 300 milliosmoles per liter. Okay, so if this concentration is going to increase because of solute, deposit, I can't say deposition. If there is increased solute concentration, it is going to lead on to an hypertonic fluid. Okay, so if there is an hypertonicity, what is going to happen? We have some receptors called osmoreceptors that is going to be stimulated. If this osmoreceptors is stimulated, it stimulates the thirst center. It stimulates the thirst center. So no subject drinks water is going to bring down this tonicity, and finally everything is fine. So this is on one side how thirst center is stimulated. Hypertonicity is one of the cause. So you have this osmoreceptor and then thirst center stimulated. Other thing, if you take hypovolemia. Okay, so this tonicity is respect to your solute. This is with respect to your fluid. So hypovolemia, and there is decreased volume. What is going to happen? Your baroreceptors are going to be inhibited. Okay, that can actually stimulate your center. The third, if you take the same hypovolemia, so when there is hypovolemia, there will be decrease in BP. You all know there will be an angiotensin system that will come up, that is going to actually cause increased level of angiotensin 2. And that angiotensin 2 will stimulate an organ called subfornical organ. So it is located below your fornix. And this subfornical organ is also going to stimulate your thirst center. So hypovolemia always stimulates thirst center because baroreceptors are inhibited. On one side, there's going to be inhibition of your baroreceptors. On the other side, if you take RAS is activated because of hypovolemia, so you have this angiotensin 2 that is going to be present in your plasma. That is actually going to stimulate your subfornical organ, and that is going to stimulate your thirst center. Okay, so hypertonicity, hypovolemia, subfornical organ. So this triangle is responsible for stimulating the thirst center. Okay, so next, regulation of ECF. Okay, so ECF volume, if you take, okay, so if it is going to be decreased, what is going to happen? So ultimately, we need to replenish our fluid levels. So this thirst center, on one side, you will have the regulation of thirst center. Same story. If there is decreased ECF volume, which means there is hypertonicity, there is hypovolemia, so this triangle will operate. Along with that, we will have a beautiful hormone that is your ADH. So what is the role of ADH? ADH from your posterior pituitary is going to act on your distal tubules and collecting tubules. It is going to cause water reabsorption. Thereby your ECF volume is going to be stimulated, or that is going to be replenished. Okay, so this thirst center and regulation of ECF, it goes hand in hand. So you can just study. Able to understand thirst center are the three factors: hypertonicity, hypovolemia, and then subphonical organ. And this is with respect to ECF. Next, endocrine role, again you all know. So we have this pituitary hypothalamic axis. So anterior pituitary, posterior pituitary. So you all know the story. So what are the hormones that is concerned with the anterior pituitary? So you have this photohypophyseal system. And if you take in case of your posterior pituitary, you'll have some neurons that is actually going to innervate your posterior pituitary, right? So you have this ADH and oxytocin, all that. So that story will include EMA. Okay, so whatever you remember, anterior pituitary hormones, posterior pituitary hormones, how it controls, that story you will write here. So I'm not touching that. Next is sleep and wakeful cycle. Okay, so in quarantine, our sleep and wakeful cycle will be different. During exam times, it will be different. And then during normal working days, it will be different. Okay, so this sleep and wakeful cycle is also going to be a part of hypothalamus. So if you take what are the centers, mainly you have this posterior hypothalamus and then anterior nuclei of thalamus that is mainly involved in your sleep and wakeful cycle. What are they? Posterior hypothalamus and then anterior nuclei of your thalamus. So these both constitute something called diencephalic sleep zone. So we all know your thalamus and your hypothalamus forms a diencephalus, right? So diencephalon. So if you take one from hypothalamus and one from thalamus, that constitutes your diencephalic sleep zone. That is going to have a regulation on your sleep and wakeful cycle. Next, basal forebrain sleep zone. So we have this preoptic area that is going to actually involve in your sleep and wakeful cycle. So all these are just memorizing points. If you're going to write this much, it's more than enough. Diencephalic, so which means structures concerned with diencephalon. So I'll have a structure from hypothalamus, I'll have a structure from thalamus. So most commonly anterior nuclei is involved in thalamus and posterior hypothalamus with all this your sleep zone. And basal forebrain sleep zone, we have this preoptic area. It's a factual point. Next, very important, that is actually operating with all of us, right? Not only for you, for us also. We have this stress that comes like a cyclone in Chennai. Okay, so cyclone in Chennai is rare, right? Similarly, we get stress very rarely. So stress, what happens? So you all know, you would have studied again your what is that? Endocrine. In your adrenal gland, you would have studied. It's a stress hormone, right? So what is going to happen is, in stress, hypothalamus is going to stimulate your adrenal cortex and adrenal medulla. So if you take for adrenal cortex, you will have this hypothalamo-pituitary axis playing a role. So from your hypothalamus, we will have this CRH, corticotrophin releasing hormone, that is going to stimulate anterior pituitary to release ACTH. And from your adrenal cortex, you will have all these corticoids that is going to be released. Okay, so this is how your adrenal cortex is going to bring down the stress. Okay, and then similarly, if you take your adrenal medulla, we will be having all your sympathetic, that is your catecholamines that is going to be released. Okay, your adrenal, noradrenal, all that will be released. Okay, so mainly if you take glucocorticoids, you all know, right? It is going to stimulate your gluconeogenesis. So there's going to be increased blood glucose level. There's going to be increased free fatty acid level. So all these are going to bring the stress down. Okay, so ultimately stress is when I can say when your cells are devoid of oxygen, when it is devoid of energy, we get this stress. Okay, so if that is glucocorticoids, it is going to stimulate gluconeogenesis. So there's going to be increased glucose level. Henceforth, your stress is going to be overcome. Okay, so this is how it is. So hypothalamus, it stimulates adrenal cortex and medulla in this way. Okay, next, a very important, reward and punishment. See, certain activities. So in our young age, no, we will have our parents who keeps monitoring us every time. Okay, so they give a slap if we do something wrong, and they just appreciate, they just give a pat if we do something good, right? So that is reward and punishment that we get from our parents. But certain activities you learn by yourself. Okay, so you will be the only person who would have involved in a particular incident, and your action would have actually would have been a benefit to them, or it could have made the situation worse. Okay, so how you are actually able to analyze your action, or how you are able to evaluate your action, is by this reward and punishment phenomenon that is concerned with hypothalamus. So you do an activity, if it is going to be beneficial, you try to know what to say, you try to make it better next time, or you try to do it in a more efficient way. So there's going to be some learning process if any of your activity is going to be good. And if there is some activity that is not comfortable, it is, you are just going to throw that off. You're not, you will try not to do that again, right? So there is going to be a learning process, there is going to be a inhibition of a process. That is your reward and punishment. So if you take reward, you have this nucleus accumbens and ventromedial nucleus that is going to actually involve in your reward, and along with that you can even include midbrain tegmentum. It's again a structure in midbrain, tegmentum. So these three, nucleus accumbens, VM and tegmentum, these three are concerned with the reward phenomenon. So what is this reward going to do? It is actually going to reinforce learning mechanism. And similarly, if you take punishment, you have this posterior nuclei and lateral nuclei involving in your punishment phenomenon, and it inhibits a particular activity. Okay, so we have this reward, and then punishment. Okay, so these are some 2 points that you must include. Very important. So which of the following nucleus is concerned with reward? So the following nucleus is concerned with punishment. So these are the answers for that. Okay. Next, role in circadian rhythm. So 24-hour cycle. So we all know certain activities happen in daytime, sometimes certain things in afternoon, certain things in night. So if you take this a picture that I have got, okay. So 6 a.m. here this cortisol secretion beginning. 9 a.m. elevated testosterone. Okay, 2 a.m. deeper sleep. Okay, 9 p.m. your melatonin will start secreting. Okay, so all these are circadian rhythm that happens in a normal 24-hour cycle. So mainly we have the suprachiasmatic nucleus that is going to involve in maintenance of circadian rhythm. So if you take some examples, as I told you, your ACTH and cortisol secretion and your sleep wakefulness cycle, all these are going to be a circadian rhythm. Okay, now in quarantine, you are all, most of your people are no sleeping at 2 a.m., 3 a.m. and getting up at 10 a.m., 11 a.m. Okay, some people you sleep at 9 a.m., get up at 6 p.m. So this all is circadian rhythm. So every day at 9 o'clock, you tend to sleep, right? If you're a practicer, that is a 24-hour cycle. So according to that, your body is going to be adapted. Okay, so that is by your suprachiasmatic nucleus, so 24-hour day cycle. So this is what jet lag, all that will come. Okay, so you go to US, so you get adapted there. So you have this jet lag. So once you come back to India, you sleep all the time in the day, and night time you're just going to be awake like a owl, right? So all this is a jet lag. So everything is circadian rhythm. So finally, we are coming on to the disorders. So I hope you understood the functions. So very important, reward and punishment, nucleus accumbens, VM and all that. Okay, so we just go through again. So we'll just finish here. Disorders. Okay, so if you take, you would have seen this movie, right? See, if you have not seen this movie also fine, need not worry. We have this Vijay TV, Vijay Super, who keeps telecasting this movie every week. Okay, so you need not worry. So unless until Vijay TV is there, we need not worry. So you all know this actor is going to suffer from a disorder. Okay, narcolepsy, right? So person tends to sleep during his work time or when he is going to get some sounds and all that, right? And even in case of the sexual, if he's trying to have the sexual behavior also, he will tend to sleep. Okay, so all these, if you take, is because of some issues with the hypothalamus. So one such important is because of hypothalamus, so narcolepsy. Okay, so first disorder that is concerned with issues in hypothalamus is narcolepsy. Second one, what can you observe from this picture? See, if you just observe the face, okay, so it is moon shaped. What is that? It is a moon shaped. Okay, and then there is going to be hypogonadism. Person is obese, right? So hypogonadism, obesity, moon-like shape, and there's also going to be mental retardation. So all these collectively is called as Lawrence-Biddle-Moon syndrome. What is that? You have mental retardation, moon-like face, hypogonadism, and then obesity. These four constitutes a very important syndrome called Lawrence-Biddle-Moon syndrome. A very important question. Okay. Lawrence-Biddle-Moon syndrome is associated with Lee Shenzhen. That can be a question. So this is your answer. Okay. Next thing, cataplexy and bulimia. So bulimia is actually an interesting one. So if you take patient, he consumes food and he is just going to initiate the vomiting because of fear of gaining weight. அதாவது சாப்பிடும் போது நல்லா சாப்பிட்டுட்டு ஐயோ நம்ம எவ்வளவு சாப்பிட்டுமே நம்ம குண்டாயிடுமே நம்மளுக்கு ஃபியூச்சர்ல எதுவுமே வந்துட்டு அமையாது அப்படி இப்படின்ட்டு he will no initiate a voluntary vomiting. That is called as bulimia. Okay, this is actually a disorder of hypothalamus. Okay, next is your Kallmann syndrome. Okay, that is again associated with your hypogonadism, anorexia. So if you take, if there's any lesion in your hypothalamus, you will have this hypogonadism because we have this hypothalamo-pituitary axis. Okay, so we have this gonadotropins coming from there, and it's also going to involve in your reproductive and sexual behavior also. So very important. Okay, so we'll just end the session. So just remember this pictures alone to recap. So you take in food, you check your body temperature to confirm your corona free. Then you drink some water, you sit in your sofa thinking about your exams, you feel stressed. Then you go for a small sleep and finally you get a reward or a punishment. Okay, and apart from that, we have all other roles. Okay, so we have seen all that. Okay, so ultimately you should know or function what is the nuclei involved, how it is going to act. A very simple topic, but a very important topic also. This is an MCQ that you must know. Okay, so I hope I made this session clear, to some extent interesting. Okay, so we will probably meet in the next session. Thank you all.